it's pretty much review. You could write down decimal multiplication and division, or you guys could write down decimal operations, that's fine. And it's the 14th today. Another reminder for you, as you're copying down your topic, Thursday we have our Math Olympiad contest. If you'd like to join us, 3:15 to 4:15, we'd be happy to have anybody in your math team. I'm expecting you there, unless you tell me otherwise. Otherwise, if you want to join us, go ahead and come on down. All right, now, the first line on this paper says when we're multiplying or dividing a decimal, we should always estimate first. Any idea why that would be a good idea, to estimate first? What do you think, Jamie?
So your exact answer will be close.
Right, so you know whether your final answer makes sense. Okay, lots of kids misplace their decimal in the answer, and then they get like 85 when it should be 850. Or they get 85 when it should be 8.5. Do you see what I'm saying? So that's why an estimate will help you. How would we estimate this first one with 3.4 times 7? What would you do, Emma?
You can either do 3 times 7, or you can do 3.5.
Good. What would be easier? Mental 3. 3.5 times 7 would be more accurate. But what's 3 times 7, kids?
21.
21. Now, is our exact answer going to be 21, less than 21, or greater than 21, and why? Caleb?
Greater than 21.
Why?
Because you have to do 0.4 times 7 also.
Good. If we remember, we rounded this 3.4 down. So that means that our estimate's a little bit less than what the real answer is going to be. Okay, so girls, I want you to do 3.4 times 7. And boys, I want you to do 34 times 7. We're going to compare the difference between those two answers. Girls, what's your answer?
26.
Okay, boys, what's your answer?
238.
Okay, so what's the difference between these problems? Or answers, I guess. What's the difference? What am I trying to say here, Michael?
The girls one is the decimal one stopped to the left.
Good. So it's 1/10, right? Less. Okay, so this one is 1 factor of 10 greater. Okay, it's 1 factor of 10 greater. Now, what do I mean by that? Well, it just means that if we had 34 times 7, we get the whole number, 238. But when we make 3.4, okay, 3.4 is 34 divided by 10, our answer would go in 1 decimal place. Okay. How about 4.8 times 0.6? Who could round that off and estimate for us? Isabel?
5 times 1.
5 times 1, kids, is 5. Okay, but we probably can tell that that's going to be pretty, what, big or small? It's going to be, 5 is going to be smaller. 5 is going to be bigger than our real answer. Why, Isabel?
Because 4.8 is less than 5, what you rounded it to, and 0.6 is less than 1, which you rounded it to.
0.6 is kind of close to what? 0.5 or 1/2, right? So I could say it's also like 5 times 1/2 or 0.5. You can write 1/2 or 0.5. And that would be 2.5. Which would be a better estimate, probably? Say, you know what? 2.5. It's going to be closer to this. But if you know you rounded a lot, 5 times 1 is 5, and you know it's going to be less than 5, then you're going to be okay. Okay? Oh, I do want you to know that to make sure that this is our answer here for our exact answer, 23.8. It's not 238. Okay. Let's do the actual math. 4.8 times 0.6. Okay, let's ignore those decimals for a second. 6 times 8? 6 times 4 plus 4? Okay, and who can tell me how many decimal places? Christopher? I need to know how many decimal places, where to place my decimal. Jamie? In between the 2 and the 8. Why here, Jamie?
Because there's 2 decimals in the problem.
Good. See how there's 2 decimals in the problem? You count those up. You do not bring it straight down. You count them up. And then you go back from the end and go back. Make sure the 2 decimal places here is also 2 decimal places here. All right, now you and your table mate, I want you to round or do the estimate and the exact answer for 2.75 times 3.1. First, who can tell me how we should estimate this one, 2.75 times 3.1, Ananya?
3 times 3.
Which equals? And more likely than not, is it going to be less than, equal to, or greater than 9? Say it. Our exact answer will be less than. 2.75, we rounded quite a bit, not a ton, but it rounded more up. Okay? All right, now, which way would be better to solve this? The 2.75 on the top or the 3.1 on the top? You would get the same answer either way, but which way is better, Sanjeev? Any idea? Which was easier? The first way is easier because you could have less steps, right? So let's not go ahead. Let's go ahead and we don't need to do it this way. Okay, it just makes your life easier. How many decimal places in your final answer? How many decimal places in your final answer once you're done multiplying? Jana? 3 decimal places. We add up this one plus these 2. All right, so when you did all your multiplication, who has an answer for me? Who has an answer for me? Marissa?
8.525.
Good, and that's just under 9. That's exactly right. Okay, lots of kids, they got 85.25. You can see they didn't add up their decimal places correctly. All right, let's go to the next slide. And instead of actually doing this, I'm going to ask you to tell me how many decimal places. How many decimal places for 6.7 times 2.3, kids?
2.
All right, kids, how many for 0.8 times 5.125?
4.
4 decimal places. Okay. 0.8 and 5.125 have a vocab word. What are they called? What are they called? When you multiply them to make a product, is their answer. What are the parts? Factors. Okay. So here's what we're going to fill in for our rule. When multiplying decimals, you're going to multiply like normal. Multiply like normal. Okay, then you're going to count the total decimal places in the factors. Okay, count the total decimal places in the factors. All right, so we did like this one, we did 1 decimal place here, 1, 2, 3 decimal places there, and all together we have how many decimal places did we say? 4 decimal places. We're going to put that in the product's place value. Okay, so if you were to multiply out that example, okay, 5.125 times 0.8, you would get a number that looks like this. Then we go back our 4 decimal places from the end. 1, 2, 3, 4. So our final answer would be 4.1. All right, quickly, I want to look at the division here. So, girls, you're going to do 954 divided by 9. And boys, you're going to do 9,540 divided by 90. Okay, girls, what's 954 divided by 9? Boys, what's 9,540 divided by 90?
106.
Oh, so what's my point here? Why do these problems have the same answer? Brian?
Well, the first one has no zeros, but the second one does. They have an equal amount of zeros in them.
Good, so it's like we multiplied the dividend and the divisor by what? 10. So we can multiply the dividend and the divisor by 10 without changing the answer. Okay? The whole reason I say that is because I want you to be aware that when you're dividing by a decimal number, the divisor can't be a decimal number. Okay, we have to multiply 10 or 100 in order to get rid of it. Your divisor cannot be a decimal number. I don't want you to find out how many times 2.5 goes into 5 or 56. We're going to rewrite that because we can't have our divisor. I'll underline the divisor so you remember that the divisor is the second one. The dividend is the first one. Who could rewrite that problem with me where we would get the same answer? We wouldn't change the answer, Michael.
560 divided by 250.
We're going to just multiply by 10, so it's going to be by 25. Good. Okay. But would 5,600 divided by 250 be the same thing? It would be. Okay. Now, this problem here, I realize is different than the one on your paper. Okay, why don't you change the one on your paper so your divisor is 0.3. All right. Who can rewrite this problem? So the divisor is not of a decimal. Christopher?
Divided by 8.
Good. Okay.